Welcome to part 4 of my ParaView workshop series. So originally I only had 3 parts planned, but I figure I'm gonna make a part 4. I'm calling it auxiliary because we'll talk a little bit about ParaView, but we're also gonna talk about how you can use PyCharm to do some post processing, and also a little touch up on PowerPoint. We're looking at mainly a few things. So plot an intersection curve is a filter in ParaView. It's a little niche, but if we want to calculate things like pressure coefficient, that's going to be very handy. I'll walk through a pipeline of how to generate a contour vector plot that looks like this on the right. Talk a little bit about flow visualization with Python. So this is a rotating Q-criterion contours animations that I generated with PyCharm. Um, should say I first thought this during a conference presentation by Professor Barbara da Silva from Queen's University. I really liked it, so I decided to borrow the idea. She did it, I think, with MATLAB using Python here. And yeah, I've wrapped up by just a little touch up on PowerPoint because quite often you're gonna generate the plot and it will be about 90% there, but it might be missing things like axes. And I find it actually easier to put them in PowerPoint and export as image when, rather than trying to whack-a-mole on your manuscript or in ParaView. Okay, let's start with plot on intersection curve. Um, so again, reading this in parallel, so it's decomposed. Now, by default, it loads the mesh because that's usually where the computation are performed and where we're interested in when it comes to CFD results. But when we're trying to plot the CP or pressure coefficient, we actually need to unclick that and load the walls instead. So now we see an actual flow surface. So the case is basically a flow over 2D cylinder at a Reynolds number of 3900. There's some perforated holes for active flow control. Now, I'm only loading the pressure field here because there's no point loading the velocity field if I'm only plotting the pressure coefficient. But what we can see that this patch still has its own basically variables or pressure stored onto it. Now, um, so now we have a kind of almost like a skin-like texture or surface. So under filter, there's something called plot on intersection curves. Now I had it on favorite because I know I've used it from time to time. Curve, plot on curve. Where there we go. Now again, you can also basically just search this up. So let's say I'm going to plot on intersection curve. Now, what that then does is kind of like having another, it's the equivalent of a slice. So let's say I had a line to the midspan, then it's going to plot the variables over the midspan. Now, you can also adjust basically the span-wise location of the curve by just basically adjusting the set origin. So you can move it. You can also rotate it. Now, as I mentioned before, the line plot in ParaView is a little restricting. So what I tend to just do is, as long as it looks fine, I just basically export it as CSV. You can also deselect some of the things that are less irrelevant, like point ID arc length. You only need the point location and the p mean mainly, and then you export it, and then you can plot it in PyCharm. So this is basically the one of the image I showed. during the introduction. So it's actually an actuated cylinder. So there's like 2D cylinders. If I show you how the geometry, overall domain looks. So 3D domain, there's a cylinder, circular cylinder, and then there's some jet nozzles that are pointing upward. Now, let's have a look at the pipeline. So first of all, I took a slice at the midspan, uh, and then I used the clip feature to clip it just so that I'm only showing a box around it. Now, the axis grid, usually I fix this on towards the end, um, but basically I changed the color, I removed the title axis. The reason is that I don't think there's a way to set the distances yet, at least not in the GUI version. I hit some of the axes to label. We only need two, we don't need all four. I tend to make the font pretty big. For comparison, default is 12. You can override this with your settings as well. The reason is that it might look big from here, but once you export it and then squeeze into your PDF or manuscript, they kind of get shrunken a lot. The last thing you want is after submission, you get asked 5 to 10 months later, hey, can you make that font bigger? And then you have to redig everything up. So you might as well get it done properly the first time around. Custom X and Y axis label. This is pretty standard. Custom bound and also a data scale because we want to renormalize the axes. Now, the next thing, in order to generate the vectors, I use resample to image. Um, the corners usually kind of gets a little weird, but we're gonna present the base flow contours instead of the resample one. The resample one is actually used to generate or seed our vectors. And this is kind of why, even though there's no flow here, there's some vectors arrow. But what you can do is that you can add a geometry like a cylinder or a box just to kind of hide it. Now, the next thing that I added are contour lines. And these are basically contours for velocity equals 0 or velocity equals 1 meter per second. Now, to generate these, it takes a little bit, quite a few steps. So, first of all, I normalize the velocity field. You mean x by 0.585. This is basically u infinity. Now, once I normalized it, it's still just a block, a whole domain. This is the operation the filters apply for every cell in the domain. And then I took a contour of 0, and then there's also at 0.1. Now, these contours are 3D because it's a 3D domain. So then what I had to do is take a slice of it. And so it kind of glitches or basically slices through and giving us a very clean thing. I tend to change them to solid color. By default, it's usually colored by, I think, UX or something. And then I made the line with thicker. You also have to crank up the ambient. Speaking of which, I should probably do the same for the contour. Just to make it brighter. And then finally, there's also the other contour for UX equals 0.1 of infinity. The last thing I tend to do before exporting is fixing the background to white. And voila, and now you can basically screenshot the output. You can also use the preview to kind of fix on a custom frame. So if I switch it back to gray, basically the window size kind of decreases, and this gray zone is what's going to get outputted if you screenshot it. The problem is I tend to like to make my background white, and then so when I preview it, it kind of is hard to see the edges. So you have to line it perfectly, and then you change your background white, and then you export it. Uh, you can also basically add your custom ones, and I've kind of annotated some of my own. Now, the last thing is the color legend. It's a little bit of a whack-a-mole, and what I tend to do is that I kind of hide it when I export the main screenshot. So I hide it, and then when I'm completely done, then I basically play around with it, make it perfect, and then I just screenshot that and paste it onto the manuscript. Um, it's two different pictures, but it gives you more flexibility because ultimately your legend size is probably going to have to be bigger or smaller. Um, the important thing is that you keep a record by save state so you know the threshold. Um, that's the most important part. And then after that, you don't even need to load the same file. You can just load a dummy case that has a velocity field, and then you can generate this. Let's talk about some of the steps on how to generate the rotating Q-criterion contours. It's pretty cool. It's a really good way of visualizing the flow structures. For us, the users, we tend to have a lot of time to play around rotated geometry, and we kind of know how it looks like the back of a hand. But at a conference, it might be tough to visualize things for the viewers, or even during a paper, if there's a supplementary online materials, it can really show them how the 3D structure looks. Now, so first thing first, I only loaded the umean. Um, there's no point exporting other variables like pmean or new tmean if we know we don't really need it. So we're gonna apply the gradient filter. This is just the same steps as before. Now we're using point data because if we use a cell data, it gets blocky, and these are qualitative results. Um, we want omega because I personally like to color it by omega, but you can also color it by other things. Then the next thing is contour. Now, as I mentioned before, the threshold it really changes from case to case, um, and in this case, the flow is transitional. So I'm using a pretty low threshold, and you have to kind of play around with it and look at other literature. Now let's color it by omega. Let's do omega set. You want to play around the threshold until you get something that you're happy with. Now that looks probably a little too small. We can also try 10. So yeah, I've done this before. So 30 is the one that I kind of like for this case. Now, uh, there's probably a way, or there's probably a couple ways to do this, but the easiest I found is to actually export it as CSV. Highlight the contour and go to the spreadsheet view. Now, these are going to be in point data. Let's only generate, I think we need the point. Might as well, okay, in this case, we'll probably keep the point ID just in case. Want to keep the criterion and omega. And then you save it as a CSV, and then we'll move to PyCharm. So I've launched PyCharm. You can do this many other ways. You can use MATLAB. You can also use Google Colab. Um, so the CSV I save is called version 4 DC50Q1. It probably won't make much sense to you, but this is how I keep track of things. Q star is basically to normalize a Q criterion threshold. So in this case, the Q criterion, I've went from 30 to 34. Now, the threshold is a threshold, so all of them is going to be the same, but it's good to still output it. So if you forget, you can open it and look at it. Uh, you don't need point ID, turns out you only need the points, location, and then depending on what you want to color it with, you also want to export those. In this case, I exported omega. So I'm gonna attach the script on my GitHub, so you can kind of chew on it and play around with it. The main idea is that you read it, you take the variables you want, you can plot other omega, other variables, and you have to adjust some of the angles. Basically, this is kind of like the elevation or how much you rotate around. And then it's gonna output two things. It's gonna give you a GIF and also give you an MP4. The output will probably give you these two files. I have a bunch here because I keep making new ones. It's a bit of a whack-a-mole. You kind of have to play around with. There's a GIF version that just keeps rotating, and then there's also an MP4 version where you can kind of control the speed. Now, if we zoom in, you can actually see that there's these little almost particles. That's because we exported the CSV as a point data. So we're not plotting a contour, we're actually plotting just points. Uh, but with the proper setting, it would look basically like a contour. And again, there are other ways of doing this, but this is just what I've done so far. The last thing we'll talk about is PowerPoint touch-up. Uh, I know it sounds kind of odd to use PowerPoint for post-processing CFD results, but I kind of slept on this for a while, and it's actually pretty handy. First of all, a few things. I have my own kind of layout, so this will probably look quite alien or odd. But I've kind of combined all of the tools I use into one tab. It takes a bit of time to set up, but you can do this by clicking on the custom ribbon. So you can see that if I toggle my default home, this is what you usually have as a base. But I kind of got tired of back and forth, so another handy tools for those of you that use PowerPoint. These are called section. Uh, for most of us, we'll probably just have everything in like a whole layout. But then once you get past like say 10, 20 pages, it gets a little hectic. So what you can do is, let's say you can do a add section, and then I'm just going to call this temp, and then you can do collapse all, and it hides everything very neatly. Remove section. Let's say we exported the screenshots, kind of cropped it. Ideally, you adjust it. The cropping is automated, or you adjust it. And then there's also a separate plugin, as I mentioned. You don't have to force yourself to have them at the same image. In fact, it's a lot easier to have them as separate images. There's a few things missing in this plot. First of all, is the axes. So we're gonna do insert equation, x divided by d, and here we can scale it up or scale it down until it matches up. And then we're also gonna label the other one. This is technically set over d. You can choose to rotate it, or you can keep it straight. And then we can also give it a label. Let's say I'm going to call this case A. Or you can just have it right above. Now, for the ligand, instead of using latex math in ParaView, you can also just straight up hide the ligand or basically only export the color bar. So, for example, this is all you got, and then you can just use latex math. So I know the hotkey, but you can also press insert equation, just all plus. So, let's say over line u x divided by u infinity. In case you're not aware, equations in PowerPoint and everything Word as well, you can use latex math. So, for example, oops, epsilon, epsilon. And if you don't know the hotkey or the syntax for it or basically the code, um, Microsoft thought of that as well. So rather than going in to dig it out, you still have to do it at least once. But let's say I found epsilon, instead of just typing or clicking onto it, if you hover over it, it shows you the code slash epsilon. So that one, if I don't know what's it called, fire epsilon. And then there's omega. And from this, you can do almost everything you can do in Overleaf or latex. The only thing that I found a little buggy is the integral with the upper lower bound. So that's the only one that why I kind of pull the integral buttons out. Um, Now, let's say you are using Microsoft Word. So let's copy over. Um, Now you can just kind of paste it, but then it becomes a whack-a-mole, right? If you have text and then it starts becoming a battle. Now you can use tables. Um, you do have to kind of copy them over one by one, paste it in. Make sure that it is either inline or text or it's not floating. So now, if you type stuff, you're moving the table and instead of moving the image. And then you can also put your latex equation. Oops. And then let's say you want to put like a case label on the left, you just insert, call this case A, you can rotate the direction, and then you can kind of go from there. Now you might say, well, now we have a table. It's kind of ugly, like, and it's pretty simple. You just basically make the grid or the table grid line invisible. So under table design, you have to highlight the specific table. You can just click no border, and voila, suddenly it looks like a float. Um, let's say I want to give it a label or like a legend, sorry, description. And I'm like, well, what am I looking at? And that's when you toggle the view grid line back on. Let's say figure one. Um, Figure one, contour of something. Close enough. And I recommend basically keeping the grid lines on. Probably want to merge this one. Ooh. Voila. And you keep it on until you're ready to submit, and then you can just basically toggle view grid line. So under view, oh wait, not that one. Huh. All right, you have to highlight the table again, and then you can just deselect it. And then if we hide the thingies, voila, very clean. Um, Another thing I recommend instead of using new lines enter is rely on the page break feature, because once you have too many of these and then you kind of add a few things, it kind of starts bouncing around all the way. Um, Page break and line break, or page break or blank page, is gonna be a lot better. Tables are your best friend. They're invisible. So if you want to work with Word, I strongly recommend using this route. You can also use the internal referencing system instead of relying on manual writing of the figure. Now, let's say you kind of adjusted it to your liking. This is really blurry. You would not probably want to submit this. I just kind of screenshot it from my paper. But then what you can do is click off them. You can group them or by pressing Ctrl G. And if you right click, you can save as picture. Now, if I open up my directory, then I called it Fig1. I went with PNG, but I think there's a couple options. And voila. So now you can either plug this directly into PowerPoint, or you can use this for overleaf and latex. It's also pretty handy if you want to add like a subplot label, let's say A and B. Those will be quite challenging to do in ParaView. It's doable, but I think it's a lot easier this way. I think that mostly covers it. Well, thank you for sitting through this ParaView series. If you have any questions or suggestions, or you want to, feel free to comment it below. And good luck on your journey into CFD.